Welcome to the Longevity Optimization Podcast, where we discuss longevity, optimal health, nutrition, peak performance, cognitive excellence, and so much more.
So, Forrest, it's a pleasure to have you here with me today.
Likewise. Really appreciate you taking the time to sit down and chat with me about this.
Absolutely. Well, today we're going to be talking about one of my favorite things, and that is red light therapy or photobiomodulation.
It's awesome. It's such an exciting space to be in right now. There's really cool research and I can't wait to dive into kind of the background tech and the research with you on that today. Excuse me.
Yeah, absolutely. So for anyone, I think a lot of my listeners do know what photobiomodulation is, but for anyone that doesn't, what's kind of like the high level overview and what got you most interested in this field?
Yeah, no worries. I love technical problems like this, and I spend a lot of time personally in the medical literature, really more on kind of a performance basis. But before we even started looking at the technology, my partner and I sat down before we started the company and wanted to define a mission for what really would guide and be a North Star for us in all of our important decisions. And we wanted to have something that would hold us accountable. And what that came down to is our mission as a company is to improve the quality of life for the largest number of people we can in the most measurable way we can. And once we had defined that, it separates us from how we've kind of approached company building in the past. Typically, we've been building companies for an exit where you want to go find and provide good value to all of your users. But that kind of the finance of that is kind of your measure for if you're succeeding or not. And with this company, we feel like it's really different. We're really really kind of tightly bound with our users. We spend a lot of time with them. We have both of our Calendlies out there for them to engage with us about things if they're not getting what they want. But long story short, with that said, we came back and did a technology deep dive on what exists as a technology, but that's either too expensive or less effective in kind of the product side that's available to people. And photobiomodulation or light therapy, the clinical level devices that were available when we started developing our products were great. The downside for those clinical level devices is they're big desktop level devices. You have to come into the clinic. Most people aren't going to be in the clinic, more than once a week maximum. Mm-hmm. And so to be able to use these on a daily basis, there just wasn't anything out there. And so taking a $50,000 to $100,000 device, how can we shrink that down into, from a cost standpoint, into something that people can afford to use at home so they can use it daily and see better outcomes because of that? And potentially even replace pharmaceutical approaches, whether it's nonsteroidal, anti-inflammatory drugs, or opiates directly. So how can we reduce the friction with the product? How can we reduce the price? And how can we make this something that's going to make a meaningful change for people from a quality of life standpoint? And so photobiomodulation was a natural fit for us on this because the outcomes from a research standpoint are way better than pharmaceutical outcomes. And you also don't have the side effects. The main thing was, how can we take something that's, again, a $50,000 laser device and put it into a sub $500 package that people can actually use?
I love that. When you say the outcomes are better than pharmaceutical outcomes, like for what indications are you guys benchmarking that?
For pain. And there's pain is a very annoying problem to solve. As we look back at this, having chosen this, so our focus right now with our first product is neuromuscular pain and inflammation, and our mission is to move the needle for people and measure that. So how do you measure pain? So with the indications we're talking about, what we've been most effective for is damaged soft tissue. So you sprain your ankle, you have an ACL tear, you have surgery, or things that are chronic inflammation driven. So anything where inflammation is driving the majority of the pain, things like osteoarthritis, we're extremely effective at treating. And again, if you've got a sprained ankle, the outcomes for this is one of our main things that we work with our professional sports teams on is tissue damage that they receive. Whether it's an ankle or a knee or a shoulder, U.S. Olympic weightlifting team, if they've got a sprained elbow, that keeps them out for weeks, and that really negatively impacts their outcome from a training standpoint. So how can we get them into a place where instead of using pharmaceuticals to take, and how the pharmaceuticals work is interesting. You're reducing the signaling of this pain, but so what we like to think of that as, or how we describe it, is you're taking the batteries out of the smoke detector, but there's still a fire going in the kitchen, and so taking those, you can actually cause more damage, both from the initial tissue that's causing this pain, and that really is undergoing the inflammation, and it's unfortunate that this has become the gold standard. I think that people have been undereducated on the downsides of the negative impacts of these nonsteroidal anti-inflammatory drugs, because it's been a gold standard for kind of doctors and physicians to say, rest, ice, compression, elevation, which we now know is not necessarily the best way to approach kind of soft tissue injuries. And in prescriptions of high and chronic ongoing doses of nonsteroidal anti-inflammatory drugs, which can cause the same tissue that you have in the first place, that you have issues with in the first place, to degrade faster. In addition to increasing chronic use of NSAIDs, and this is not something that I think is commonly known, but if you're using nonsteroidal anti-inflammatory drugs on a daily basis, you're increasing your level of risk for cardiovascular disease by 50% across the board, whether you're 6 years old or 60. Like that's a really huge,
massive,
unknown.
Yeah. Wow, that's amazing. And let's talk about wavelengths, right? So what's the difference between what you're doing and then maybe like a standard red light panel?
So we use two wavelengths. We use 660, which is a deep red, and 808 nanometers, which is a near infrared. And the difference in those is there are panels using these wavelengths out there, but the difference for these is that light therapy is something, or photobiomodulation is something that is essentially the outcomes are driven based on dosing. And so the dosing is based on photoacceptors and at what depth of tissue they exist and in what order of magnitude of quantity they exist. When you are dosing with a panel, if you want to be able to use that panel to dose internal tissue, you have to turn up the power on it so high, because the emission is so broad, that anything that is at the superficial levels of tissue is wildly overdosed from an impact standpoint. So our goal with with the tens of thousands of hours our team have put into modeling mathematically and then testing in reality what these physiological adaptations are and what these physiological triggers and downstream impacts are from a molecular standpoint. The goal for all of that work from a modeling standpoint is to be able to optimize the photon delivery to the correct photoacceptors at the correct depth of tissue. And again, if you're overdosing some and underdosing others, then you're really not getting the optimal outcome for any of this. And so that's really where our targeted laser therapy makes a huge separation from an outcome, from an impact on the physiology versus what you might see from panels. And one other thing on the panels is, if you're 2 inches closer or 2 inches further away, the dose on that changes massively. And so it's really hard to even model what's the correct level of dosing if you can't control very, very specifically with these with the distances for this. There's the inverse root square law just means that you drastically take down the dosage every inch that you're away from the panel.
Yeah, that's such a great point. So your device, you're putting it directly onto the skin. So I first learned about your device actually at a Da Vinci 50 conference from Ben Greenfield, and a friend of mine had a headache, and he pulls out this Kineon device and some magnesium and just put it around the neck, and it seemed to work pretty rapidly, which was absolutely amazing. But it's different than standing in front of a panel or, exposing even like a face mask panel. It's like direct contact with the skin. And I feel it's a very different feeling. I mean, when I use your medical grade laser, essentially, you feel something happening. It's not just warm, like you actually feel it penetrating, which I love.
Yeah, it's and Ben actually called that one very early. He the neck applications, there's 2 huge blood vessels going into your neck there, and it's really powerful for being able to interact. We interact with a couple of different photoacceptors, and one of the most common ones that's just available in all parts of your body is hemoglobin. And so for hemoglobin, there's 4 binding sites where hemoglobin either takes on, hemoglobin's kind of a carrier molecule in your blood. And so if we're in high school chemistry class, we're thinking about kind of hemoglobin carrying oxygen to your cells. Those oxygen binding sites for hemoglobin are actually competitive for nitric oxide as well. So when you trigger those with primarily the 808 nanometer wavelengths, it causes the dissociation of the nitric oxide from these binding sites. So that does a couple of cool things. They're actually kind of additive in their outcome. One is you dump nitric oxide into your blood vessels and is a dilating factor, so it causes your blood vessels to expand and more blood to come through. The second is you open that binding site to be able to bind oxygen. And so you can actually deliver oxygen more effectively and deliver blood more effectively from 2 different aspects just from treating this. And then one of the interesting kind of aspect of that as well is that nitric oxide interacting with the cardiovascular endothelial tissues or kind of the walls of your blood vessels actually trains the walls of those blood vessels to reduce stiffness and increase flexibility. And they test that at the lab level with a metric called shear strength, which is essentially as you have a tube or a pipe, how much pressure that friction puts on the tube can actually break the tube or break the pipe, or in this case, the blood vessel. And the more flexible that blood vessel is, the higher level of shear strength that it can hold. And there's been really kind of unequivocal data on this nitric oxide release in your blood training over time. And it's a month scale thing. So it's kind of consistency of treatment for months, but it trains your cardiovascular tissue to be more pliable and to be stronger. And it's a really exciting thing, especially for our older users who may have some level of stiffening in that cardiovascular tissue.
I love that. So if you're doing it on joints, let's just say, is there a systemic benefit of using the device?
Yes. And it's so exciting to be in this space from a research standpoint that we're working with a lab in Japan who have done a number of research papers on this, but there's been 3 main areas of the body that we've seen really powerful research around what they call remote photobiomodulation. So treating in one local tissue, but expecting either regional or systemic impacts or impacts in another tissue area of the body. And to go into a few of those, one of the ones that's been most exciting for us, and we're actually going to base a product release that we have coming up next year around this, is fertility tests that this lab in Japan was doing. And they developed what they call the proximal priority therapy, which is essentially treating those huge kind of blood vessels in your neck, and then also treating at the base of your skull. And so they use the kind of laser and then point it towards the front of the brain, kind of like you'd be like making a unicorn horn out in front of your head with that direction. And what they found with this was, and this was roughly I think it was 229 woman study with women who had been selected based on minimum of 5 years of infertility. And they found that 29% of the patients were able to get pregnant within 8 months of treatment, and that 22 brought that pregnancy through to a healthy delivery. And got a bird coming in to say hello.
You know that.
Everybody's interested.
We're filming in the jungle.
It's such a beautiful view here, by the way. But so this is something where you really wouldn't anticipate this. Like, how is it's almost kind of just triggers these questions of how is that happening? And we have some of these kind of mechanistic operations that we know of, but there's others that are kind of being delineated by this research in the space. But treating the neck and then seeing this fertility changes is one of the big places where we've seen this remote photobiomodulation be used and tested. And again, we ended up in contact with this lab because of essentially our users who had been flagging for our development team, our research and development team, that they had been using the devices for endometriosis and seeing really powerful impacts. And so it started our research team down a couple of rabbit holes on why we don't see more applications for female pathologies and why we don't see more research for female pathologies, which is really kind of a shame. I think I mentioned to you off camera that, one of the things that we'd seen as a part of our research into this space was the amount of research dollars going towards erectile dysfunction, male erectile dysfunction versus endometriosis in women is over 1,000 to 1, which is just crazy. It's almost like, how does that happen?
I know. I mean, I just did an interview with Dr. Jennifer Garrison, who is really a leader in, female reproductive aging and what happens. And we do know that, our female reproductive organs are aging at about 2.5 times the speed of other organs. So it's the fastest aging organ in the body, but we don't know why. We don't know what that mechanism is. You and I off camera kind of discussed some of the possibilities, right? The exponential increase in inflammation during menstrual cycles and in general inflammatory tissue in our reproductive organs could be, the density of mitochondria that we have that might be dysfunctional. It could be a plethora of things, but it's exciting because when we find something that's helping to resolve issues and symptoms of, underlying disease, then it also might give us a peek into, why is the aging process happening in general. But I'm also so excited because I know women with endometriosis and PCOS and other, and in general, just, cramping, around menstruation. That's something that, I believe is multifaceted as to why, but there aren't a lot of good resolves for that. So I know you guys are looking into that as well.
Yes, we're super excited to be able to, we have a research and development team that skews male, and it's not something that was really kind of a natural. We were looking at things like muscle recovery and pain reduction and joint tissue. How do we help people kind of regrow cartilage in a meaningful way when it's been worn down by these type of inflammation issues over time? But finding something like this where, like you mentioned, there's a really high density of mitochondria. That's what we interact with our photoacceptors. And in the mitochondrial phospholipid bilayer, there's in that electron transport chain, there's a blockage, kind of a bottleneck for energy production, and that enzyme, so cytochrome C oxidase, we interact with directly, and so it shifts much more energy production from a mitochondrial standpoint. But one of the things it also impacts is that mitochondrial retrograde signaling between the mitochondria and the nucleus. And in that space, in that kind of inside the cell space, what we see is there's a really powerful mechanism from light therapy to be able to balance this oxidative stress. So if the oxidative stress is too low or too high, you end up with different pathologies, but you end up with pathologies out of that. They're both negative impacts. And what we found very clear from the research is essentially you can, whether it's low or high, you can stabilize that oxidative stress back into a healthy range by applying this, particularly the 808 nanometer to that the cytochrome C oxidase enzyme in the mitochondria. And so there's a lot of signaling where I try to steer away from the biochemistry, but it's just so exciting to see these outcomes that we can really come back and impact people's lives in a powerful way in line with our mission. And the early kind of anecdotal inputs we've had from our user base kind of flagging this of, hey, I'm at a 8 out of 10 in pain, and being able to shift that to a 0 to 1 out of 10 within 30 minutes of treatment. That's something we really couldn't kind of look away from. It's exactly in line with our mission as a company. And so we've now spent, thousands of hours of our team research and development around how do we model the correct delivery of photons to the correct photoacceptors in this space. They're going to make meaningful changes around these pathologies, whether it's infertility or you mentioned polycystic ovarian syndrome, or really the unbelievably high levels of inflammation that women undergo on a monthly basis. It's orders of magnitude higher than anything else in the human experience, and it's it's one of those things that wasn't natural for us just from the basis of our team. And hopefully that's what's been the kind of the blocker for getting these type of products to market, is just the natural awareness around it. But it's just exciting for us because we're now in a space where we can take a technology that we're dialing in better and better on a daily basis and apply it to problems that have had less visibility and less education and less research and funding. And so being able to provide outcomes like that is super exciting for our team.
I love that. And so in the study that they conducted in Japan, they were using it 1 time per week,
That's right.
the photobiomodulation. And then with your new device, which I don't know if you have any idea when that'll be launching, but more like a femtech product, what will the protocol be with that? Or how can we use Kineon current device offering to get some of those fertility, endometriosis, cramping benefits?
No, I love it. Awesome questions. So they were using this once a week because they had to have, and very similar to how we came into developing this product in the first place, was you had to have people come into the clinic, and it's just not very kind of convenient to be able to do that on a daily basis.
Yeah.
You can actually drive better outcomes for this by treating on a daily basis. And we try to reduce the friction points to make it as easy as possible for people to build meaningful habits around that to help them kind of keep consistent, because that's what really drives the main results. But we're releasing the product, the Femtech product, the Bloom Plus, next summer.
Exciting.
So exciting. And depending on what you're treating, so with endometriosis, again, what we've seen, and again, this is anecdotal, and we're in the range of I think 30. We when people provide us feedback from our community of users, we track it in our database, and so I think we're at about 30 anecdotal stories of how this has moved the needle for people from a pain and inflammation and discomfort standpoint. So when treating endometriosis, that can go in as short as a 10 to 15 minute treatment one time. For fertility, that's ongoing. And so it would likely be around 10 minutes per day in an ongoing way. And then there's a number of other things like polycystic ovarian syndrome, where we're still dialing in the dosing models in the most effective way we can. But with kind of menstrual cycle and dysmenorrhea, it would be essentially as needed. And so maximum of 15 minutes twice a day. But we have seen really powerful impacts for that as well. And those are using our existing product, where we have the red is not really, the deep red doesn't penetrate far enough for that to really have a massive impact from an outcome standpoint. And then we have the 808, which is a good wavelength, but it's I would say if we had to kind of just give it a rough order of magnitude from a percent correct, that's about 50% right from a dosing standpoint. With the new device, we're working with 808, 940, and 1064, and these additional wavelengths have been much more thoroughly researched over the past 2 to 3 years. Like that literature didn't really exist from 5 to 10 years ago. But what we're seeing is that those wavelengths actually add powerful impacts from an outcome, from a needle move on the outcome for more deeply embedded tissue. So they've been used most effectively for brain tissue. And again, you have a skull, or in my case, a very thick skull that's this kind of in between. And so the penetration rates for the brain need these slightly longer wavelengths of near infrared. And then for tissue for gut and uterine tissue and ovarian tissue.
I love that. Well, you have to let us know as soon as that launches, because that's so exciting. I mean, fertility, all of these issues that we've, talked about this device targeting are such a big issue. Just cramping and, being uncomfortable around that time of the month. So super exciting. What are your personal protocols for your device?
So one of the things that I started as a test around this time of the working with the Japanese lab from the proximal priority therapy was treating these kind of large blood vessels in the neck. And I've kept that up because, so I treat that every morning for about 15 minutes. And I feel more alert, more awake. And there's a term they use in the medical research called affect. So my general mood and just kind of calmness, with building a company like we are now, small business, there's always a lot of stress. There's a lot of things happening. There's so much to get done and never enough time in the day. And so I find that if I do this, my stress levels feel lower, and I feel less stressed, and I feel calmer and more able to manage kind of my cognitive kind of load for the day.
Yeah.
And the second one is my gut. And the gut I started very, very similar time as this proximal priority therapy. And the outcomes from the gut, one is that you actually, that should be impacting the affect and mood as well. Mm-hmm. Your gut is kind of your second brain, and you generate a number of different neurotransmitters like dopamine and serotonin in your gut. And so it's a really nice way to be able to trigger those and increase those. But the kind of side effect of that is I just don't get sick anymore. And there's a really powerful amount of research going on around gut health and the gut-brain axis, and what's expanding out from gut-brain axis into things like gut-brain liver, so that the gut-brain plus is how they're referring to these. But the main thing for me is I have a 5-year-old and an 8-year-old at home, and they bring in colds from school occasionally, and it used to be something where the whole family got a little bit sick. It would just kind of be a cascading waterfall effect. But that's been completely nullified, and I just don't get the common colds anymore. And that really lines up with what we're seeing from the literature from an immune standpoint and from an autoimmune standpoint, to the point where there's a couple of different groups, and we don't work with them specifically, but we do follow their research on this, that are finding powerful impacts on autoimmune disorders like multiple sclerosis and asthma by treating the gut with lasers. And so we actually are just now launching our gut product. Our gut product is really kind of focused on, it's a difficult one to describe because with a lot of the photobiomodulation research, the mechanisms are very well kind of laid out. With the gut, what we have is we kind of have the AB and the YZ, and so we know what wavelengths and what powers and et cetera, and then we know how this is moving the needle from a large body of people, a large body of patients being treated for autoimmune disorders or tracking their immune outcomes. And there are a few of those kind of scattered letters that we have in the alphabet that help us kind of understand what's actually being triggered there. But a lot of them are still yet to be parsed. And so there's some really exciting work happening here from a research standpoint. But a few of the things that we see triggering some of these downstream impacts are the inflammation in your gut can often trigger leaky gut. So the tight junction in your gut open up, and some of these different inflammatory proteins from your gut start leaking into your blood, and you start seeing systemic impacts. And again, those can trigger downstream autonomic issues and downstream autoimmune and immune issues. And so there's a number of things that can trigger from a negative pathology or outcome standpoint. But the main thing that we're seeing is these outcomes are shifting. And so being able to dose the gut in a powerful way to reduce the inflammation, to tighten those leaky guts, to do things like move the FB ratio, which is a ratio by which we measure two different types, the balance of two different types of bacteria in your gut are, that's a really clear outcome that we drive from a laser intervention standpoint. I would say there's a couple of other things that kind of mediate those outcomes. But the main thing for us is that, again, in line with our mission is it moving the needle for people? And when you can see people getting less inflammation in their blood, when we can test for less inflammatory cytokines in the blood, when you could test for reduced levels of C-reactive proteins and creatine kinase and things like this, there's really powerful indicators that this inflammation that's starting in your gut ends up in places that is going to cause much more dramatic negative long-term impacts, and being able to kind of remove that is such a powerful tool.
I love that. So you're doing, for the protocol for the gut, you're doing 15 minutes a day. Are you doing it directly on the gut?
I am. Okay. Lower gut. And then there's actually, I need to add this one in as well, but there's been a couple of recent studies on the duodenum. So treating kind of the area of connecting your stomach and your small intestine, and seeing very powerful outcomes from that as well. So I'll probably add that one in too, but so far it's been kind of lower gut.
Love that. And you're doing it for about 15 minutes per day, right?
That's right.
So we have the gut, and then we're also doing the brain, right?
That's
Essentially to help improve the lymphatic system. And if you can talk a little bit about that, that'd be wonderful.
Absolutely. So one of the things that we see when people aren't getting enough sleep is that you aggregate a lot of protein wastes in your brain. And you have this system. So a lot of people know about their lymphatic system, but maybe not about the glymphatic system, which is essentially the combination of your lymph system and these glial cells, these kind of waste removal systems in your brain. So the combination of those, glial and lymphatic. And so, with me, if I'm not getting enough sleep, again, building a business, it's always hectic. You're just kind of trying to get what you can done. And we try to stay as good as we can about sleep and recovery, but sometimes you just don't have the time for it. And so, if I every morning I treat my neck, if I have had a poor sleep or a lack of sleep or sleep impacted by, going to Asia and having jet lag, treating the glymphatic system behind the cheekbones. You can actually treat your prefrontal cortex as well with this. And then treating your neck is a really powerful combination where you sense this, the cognitive kind of decline that you would expect from having not slept very well is minimized if it's there at all, and you just feel much better. And again, this is very much in line with what we're seeing from the medical literature as well. There's always a kind of potential placebo effect, but even with these randomized controlled trials where placebo is accounted for, these outcomes are exactly what people are seeing from this. Is your cognitive abilities kind of take a tick up, and that's the short term kind of impact. The longer term impact is having waste material in your brain is really not good for you. And we can't say it's necessarily directly causal, but it's extremely highly correlated with dementia, depression, anxiety, Alzheimer's, a number of different negative pathologies, which we interpret from our team as metabolic impacts long term, but somewhere between the metabolic impact, the microvascular impact, and these kind of protein waste impacts. We're ending with tau proteins there for we're working on a number of different studies with a brain product that we're developing that'll be out over the next 18 months. But yeah, Alzheimer's and dementia are just terrible, terrible pathologies, and not just for the actual patient, but for their entire family. It really has a powerful negative impact on an entire range of people around the patient, around the user, and being able to measure microvascular and then treat microvascular impairments is a really powerful tool for this. And so we're going to be bringing that out over the next 18 months. It's an incredibly complex product because the imaging that we're building into it. But we've really seen there's been a repeated kind of issue with using the protein only kind of hypothesis for Alzheimer's. Certainly you see increased proteins. So these waste proteins, tau proteins in your brain that are associated with Alzheimer's. But whenever pharmaceutical companies can address those, they can reduce the tau proteins, but that doesn't change the outcomes from a cognitive decline, and it doesn't change the outcomes from really any of the symptoms from Alzheimer's. What has actually moved the needle for people in this space is and this is still a hypothesis, but I think our team is pretty well on board with it right now, is the microvascular hypothesis of Alzheimer's, which is the impacts of this microvasculature impact, negative kind of constriction of these microvascular patterns in your brain means that you can't deliver oxygen and you can't use energy in the same way. So you have a metabolic impairment there, and it puts your brain has a number of different overlapping metabolic systems, but when you have one that's powerfully impaired, it puts strain on others, and longer term, those tend to break down as well. So there's a really kind of great hope in the research right now that by being able to release nitric oxide and retrain that microvasculature in your brain to be able to operate more like it does when it's healthy, that we can steer people. We can both early diagnose and then also steer people out of these negative paths that they're on with the Alzheimer's and a couple of other types of dementia as well.
Very exciting.
Hi guys, I'm going to interrupt this episode for a brief announcement. As you may or may not know, I started a community for females by females, and it's a female longevity optimization community. This is a place that you can connect with like-minded women. We are all here to support each other, and there's a variety of different benefits to being a member. You get a monthly Ask Me Anything, so submit your questions and I'll answer them directly. We also have an entire library of courses on all of the important components of longevity, such as labs, nutrition, exercise, sleep optimization, longevity optimization protocols that I'm doing, along with real-time updates to my personal protocols. There are so many benefits of being a member of the community. We'll also be doing in-person live events here in California and virtual events for anyone that can't attend. But if you're interested in joining the community, I would absolutely love to see you there, and I will include a link in the show notes.
I mean, it's interesting because we used to spend so much more time in the sun, right?
Yes.
And the sun actually provides a lot of infrared and red light. I don't think that's as known as it should be. But I mean, it's so many reasons, I believe, that we are kind of in this chronic state of disease. But I think, just that is also one of the big issues here. But now you're taking that, it's like harnessing the power of the sun, which we know is meant to heal by nature. And you're able to apply that in a very localized, direct, powerful way.
Yes. And I think that's it's something that we've kind of also seen from our team is actually as people start researching into the space and as we spend more time with researchers around this topic, you find that everybody actually starts kind of planning in daily sun time to kind of start recharging the battery a little bit. I think, our goal with this from a measurability standpoint is to understand how we're triggering that, how we're, one of the things, and we were just touching on it with the brain side as well, is, and you see it very directly from a sunshine standpoint as well, is improvements in metabolic function, essentially. So if we can, one of our goals as a company is to be able to say, how can we measure metabolic function in a way that's going to allow people to understand when they need that, and then if they don't have the sunshine available, you're in, our head of research is in Finland, so they got like 4 hours of sunlight a couple times, like for months at a time.
That's tough.
So how can we most optimally provide this, and also there's a balance with sunshine. I think something like 60 to 70% of it's infrared, but you also have UVA and UVB, and so there's a limit to how much of the infrared you can balance with that kind of more. So there's and just for kind of listeners on this, it's an interesting piece because the infrared actually adds photons to these photoacceptors. Things like UVA, UVB start knocking electrons around, and you start seeing kind of degradation and potentially of DNA, RNA from those impacts. And so there is an amount that your body can healthily live within, but also we don't know those boundaries as effectively as we could for the UVA, UVB exposure, and the amount of knocking around of electrons they're doing. It also tends to kind of vary more on a person-to-person basis. So it's our goal is to be able to provide a low-risk way of being able to do this in an optimal way and fix these metabolic impairments and measure, identify, and then fix metabolic impairments depending on which part of your body you're doing it in, because we often get it's a very reasonable question. How is it that I shine light on my body and then these physiological adaptations start happening? That sounds like snake oil. That just sounds so fantastic. That it's almost unbelievable. But it's something that we kind of also know from an intuitive standpoint, right? Where you're triggering melanin, right? All right. How did you get, you shine the light on your body, and then at these more superficial levels of tissue, you get a tan or you get a sunburn. There's an intuitive level of these kind of photon delivery adaptations that we know. But when you look at it from we know about these, how do we optimize those relative to what wavelength, to what power level, to what is pulsing helping? All of these things have an impact on it. And so when you can put that direct feedback loop, and as an example for a direct feedback loop, we mentioned hemoglobin. When we trigger hemoglobin, we expect dissociation of nitric oxide. Well, that increases your serum nitric oxide, how much nitric oxide is in your blood. We have optical ways of measuring that now. And so when we can put those short-term feedback loops in place from a measurement and dosing standpoint, it means that we can advance what we're doing from a delivery and outcome and adaptations that we're actually planning for, and then triggering and then measuring. And so, again, it's a very exciting space to be in, because when you apply that back to uterine lining, when it's highly inflamed, that's reducing that inflammation. It has a powerful impact on that person's comfort and pain level for the day. But when you tell somebody we're gonna use to treat uterine lining and osteoarthritis, even though it's the same mechanisms we're looking at to reduce inflammation, essentially what we've got is an inflammation reduction machine. But it just kind of begs those questions of how can you treat all of this and provide reasonable outcomes for these different things? And we try to do as good a job as we can of educating about those systemic impacts. So what are we triggering, and then what are those downstream signals, and then what are the outcomes that are driven by that? But kind of all it comes back around to inflammation in a roundabout way.
So in a just short, concise way of how red light therapy is working, and I totally agree with you. We can't harness the power of the sun in such a prolonged and powerful way to treat the conditions that you are referring to. But my mind always, when I think about mitochondria, one of the biggest things I think about is sun exposure, cold exposure, like living more like our ancestors used to live, because their mitochondria was so much better. And we know that our mitochondria nowadays are just like a complete disaster, essentially, and unfortunately, in the food system and all the things that we're doing to harm it. So is the mitochondria kind of just like eating up the light wave, and then it's becoming more powerful because of that?
So in your mitochondria is almost like a cell within a cell. And there's some theories as to how it developed. But essentially, the mitochondria lives within your cell. And in the cell wall of the mitochondria, which is also referred to as a phospholipid bilayer, you have this electron transport chain where you essentially generate energy. And it's the most prolific way that we generate energy as humans. And there's a bottleneck in that process. There's 4 stages of that electron transport chain. In the 3rd stage, there's an enzyme called cytochrome C oxidase. Cytochrome C oxidase is a photoacceptor for both red and infrared wavelengths. And when we trigger that cytochrome C oxidase, we move the bottleneck. We remove the bottleneck from that step 3, and it becomes step 4 of that kind of 4-phase process in the electron transport chain. Which is why it's also interesting, just as an aside, if you're able to use methylene blue at the same time, the photobiomodulation removes the 3rd phase as a energy production kind of bottleneck, and then the methylene blue removes the 4th phase, and so you kind of you get almost a euphoric feeling from those, because if you're using both at the same time, because of the amount of energy you're able to produce. But this is so this cytochrome C oxidase is one photoacceptor that we trigger. I would say that the main 3 that really trigger impacts in the body are cytochrome C oxidase in the mitochondria, increasing the level of production of energy, the hemoglobin in your blood, which is just like everywhere in your blood. It's the most common carrier kind of molecule in our body. And then calcium channels, calcium ion channels in our cells, which kind of are gates into and out of our cells and regulate a number of different things from how external to cell molecules come into the cell, and also even things down to how your muscles work, how you can kind of move, and trigger these movements neurologically. So those are there's more, but those are the primary three, just from a scale standpoint of photoreceptors that we interact with in the body. And the combination of those three is really powerful. So we talked about hemoglobin opening up the blood vessels and increasing the amount of oxygen delivered there. With the cellular level signaling, the oxidative stress balancing, kind of that signaling, that mitochondrial retrograde signaling between the mitochondria and the nucleus, and reduction of or balancing of the oxidative stress, and then with the calcium ion channels. There's a number of things and that's actually a deeper rabbit hole to go into than maybe we have time for today. But the combination of those really is the trigger that around damaged tissue. So if you have dramatically damaged tissue from an injury or again, chronically damaged tissue in a joint from something like osteoarthritis, what you'd like to see is reduced inflammation. And again, those are measured in some very specific blood draws that we do. And we see, 70 to 80% reductions in chronic cytokines, in creatine kinase and C-reactive proteins are a few of the markers for that reduced inflammation. And then you see increased growth factors. So because your cells actually can now grow because of the additional energy that they're generating, that additional proliferation of specific types of cells from a healing standpoint is something that you see take off much more around this traumatically damaged tissue. So, and then a couple of the support functions that are also triggered by this: increased proliferation for type 2 collagen, which helps with scar tissue, as an example. So if your scar tissue is going to be much faster and much faster to heal and recover, much more pliable and much more similar to the original tissue in the area. And stem cells. So mesenchymal stem cells, and this is actually a very exciting one because we're actually starting to work with a couple of different stem cell laboratories on kind of human applications for this. Mesenchymal stem cells are kind of stem cells that can turn into anything if they're around a damaged cartilage, as an example. What you'd like them to turn into is chondroblasts, which is the front end fast growing cells for soft tissue. And they do. They increase their rate of turning into these chondroblasts by about 3 times. So same thing for osteoblasts. If you've got a broken bone, as long as the ends of the bone are together. If they're open, it doesn't work for some reason. We don't know why yet. But if they're together, you can regrow bone faster. So there's some really exciting pieces about that from a downstream signaling standpoint. But those are the primary 3 photoreceptors that we interact with from a volume standpoint.
I love that. Well, I mean, I love your device. I'm a big fan of it. I can't wait to use some of these new ways that we talked about today. Can't wait to do it with methylene blue. Big fan of methylene blue too. So I have some upstairs. And the brain product is so exciting. The female product is so exciting. I think we're going to have a code that I'll drop in the show notes for all the listeners, and something that you can try at home from recovery. I know that's where you guys started, right? And like injuries and pain management. But I love that you're finding all of these new applications for such an incredible device. So
thank you so much. I really appreciate it, and such a great discussion. What awesome questions, and this is an amazing platform. I really love the education you're doing with your listeners, and hopefully everybody's loving this out there, because there's some really powerful things you're talking about here.
I mean, absolutely. It's like we're able to take our healing into our own hands, which I just think everyone not only has it right and should be doing, but it's so powerful.
That's awesome.
So thank you so much for being here.
Thank you for having me. Really appreciate it.
Yeah, thank you.
This podcast is for informational purposes only, and views expressed on this podcast are not medical advice. This podcast, including Kayla Barnes, does not accept responsibility for any possible adverse effects from the use of the information contained herein.
Opinions of their guests are their own, and this podcast does not endorse or accept responsibility for statements made by guests. This podcast does not make any representations or warranties about guest qualifications or credibility. Individuals on this podcast may have a direct or indirect financial interest in products or services referred to herein. If you think you have a medical issue, consult a licensed physician.